formula is where we're going to pick up. Use the midpoint formula to do each of the following. Find the coordinates of the midpoint with 2 endpoints, and find the coordinates of the other endpoint if we have one endpoint and the midpoint. So the midpoint formula is basically finding the average of the x's and the average of the y's. So you know to find the average, you just add up your two numbers and divide by 2. So essentially to find the midpoint, you're just adding up the two x values, dividing by 2, adding up the two y values, and dividing by 2. So it's pretty straightforward. In part A, to find the midpoint, we are going to add the x's, 8 plus negative 6 divided by 2. And then we're going to add the y's, negative 4 plus 1 divided by 2. And you just simplify those two fractions. 8 plus negative 6 is 2 over 2. Negative 4 plus 1 is negative 3 over 2. So that midpoint is going to end up being, at the ordered pair, 1, negative 3/2. So we can use that midpoint formula also to work backwards, because we are given in part B, they give us the midpoint. So I know that the coordinate of the midpoint is 8, negative 2. And I have to figure out where the other x and where the other y are. So that means I know one of them is negative 6. And if I add the other x value and divide by 2, that's going to give me 8. And for the y's, I know one of them is 12. So if I add 12 plus my other y value and divide by 2, it should equal negative 2. So I can kind of make myself two little tiny equations here. I know that negative 6 plus x divided by 2 has to equal 8. Which then if I multiply both sides by 2, I get negative 6 plus x is 16. And then add 6 to both sides, I get x should equal 22. And then I'll do the same thing with the y's. I know that 12 plus y divided by 2 has to equal negative 2. Multiply both sides by 2 gives me 12 plus y equals negative 4. And then subtract 12 from both sides, I get y equals negative 16. So that gives me the x coordinate for the other endpoint and the y coordinate for the other endpoint. So the other point would be at 22, negative 16. Applications in the midpoint formula. They've given us this graph that might indicate the increase in sales generated by fast food restaurants from $167.7 billion in 2011 to $233.7 billion in 2017. So we're going to use the midpoint formula and the two given points to estimate sales in 2014. So what they're banking on is us making two ordered pairs. The first ordered pair is 2011 and then 167.7 billion. The second ordered pair is 2017 and $233.7 billion. And then if you think about the midpoint of 2011 and 2017, if I add those together, 2011 plus 2017, and divide by 2, that is 2011 and 2017 is 4,028. And I divide that by 2, that gives me 2014. So the midpoint can be found, the amount of sales in 2014 can be found just by doing the midpoint. So I'll do the same thing with my y coordinates, add the 167.7 billion plus 233.7 billion, and divide by 2. 167.7 plus 233.7, 401.4, divide by 2 is going to give me 200.7. So that's telling me that in 2014, sales were $200.7 billion based on the midpoint formula. If I look at the graph and I go halfway between 2011 and 2017 and I estimate that maybe about here and then follow that up on my graph, that's somewhere between 180 and 210. So that seems reasonable. The model is a little bit hard to look like, just eyeball it, but the actual figure is 195.4 billion. So we were a little bit higher based on our midpoint, but it's really very common for the model that we use to be a little bit slightly off from what actually happened. So I wouldn't be too concerned about that. All right, moving on to equations in two variables. Ordered pairs are used to talk about the solutions of equations in two variables. So for each of these equations, they want us to find at least 3 ordered pairs that are solutions. So what we're going to do is we're going to choose any real number for x or y, and then substitute into the equation to find the value of the other variable, and then make an ordered pair. So on this one where we have y equals 4x minus 1, we could just pick anything we want. So if we just pick x equals 3, then we would have y equals 4 times 3 minus 1. And then we work through that. 4 times 3 is 12. Minus 1 is 11. So we make that into an ordered pair, 3, 11. And then we just do that a couple more times. Hang on, I think on the next page I have a graph. Yep, so I want to make sure everything can fit on there. So we can pick another x value. Let's pick x equals negative 2. Then y would equal 4 times negative 2 minus 1, which is negative 8 minus 1, so negative 9. So another ordered pair would be negative 2, negative 9. And then maybe 0. If I pick x equals 0, then y would be 4 times 0 minus 1, which is negative 1. So that ordered pair would be 0, negative 1. Moving on to this next one. X equals square root of y minus 1. Well, this is different. This time I'm going to pick values for y. And I'm going to pick a number that's nice. I know that I'm going to subtract 1 from my y and then take the square root. So I'm going to pick something like 10. That way, when I do x equals the square root of 10 minus 1, I'm actually taking the square root of 9, which makes a nice value. So when I substituted in 10 for y, I got 3 out for x. Now my ordered pair is 3 in the x space and 10 in the y space. So make sure you're getting those numbers in the correct spaces. Then let's pick if y is 5, because that'll come out nicely. If y is 5, then x would be square root of 5 minus 1, or square root of 4, which is 2. So that ordered pair would be 2, 5. And I can't pick 0, because if I pick 0, I'm going to do 0 minus 1. I'm going to get negative 1. And the square root of negative 1 is not a real number. So I will pick 2. Then x would be square root of 2 minus 1, which is square root of 1, which comes out to be regular 1. So if x is 1, y is 2. So that's the ordered pair 1, 2. In C, we're back to y equals. So I'm going to pick x values and plug those in. So we get to choose. I'm going to pick, a negative number. I'm going to pick 0. I'm going to pick a positive number. So if x is negative 2, then y would be negative 2 squared minus 4. Negative 2 squared is 4, and 4 minus 4 is 0. So if x is negative 2, y is 0. When x is 0, y would be 0 squared minus 4, which is negative 4. So that's the ordered pair 0 for x -4 for y. And then when x is regular 2, y is 2 squared minus 4, which actually comes out the same as it did when x was -2. So this ordered pair will be +2 for x and still 0 for y. Keep those points handy because what we're going to do is we're going to graph each of those equations that we talked about in example 7. So we're going to talk about finding the graph of an equation by plotting ordered pairs or points. But I specifically want you to pay attention to the intercepts. Intercepts are where lines cross the axis, the x and y axis. So the ooh, that is a very dark highlighter. Hopefully you can still read that. Don't use that dark of a highlighter on your page. Intercepts are where lines on graphs cross axes. So the y-intercept is the value of y when the x-coordinate is 0. So to find the y-intercept, we are going to substitute in 0 for x. The x-intercept is the value of x when the y-coordinate is 0. So to find the x-coordinate, we're going to substitute in 0 for y. To graph a line by plotting points, what we're going to do is find the intercepts, the x-intercept and the y-intercept. And we're going to do that how we just talked about. Then we're going to find as many additional pairs as needed, ordered pairs as needed, plot the ordered pairs, and connect the dots with a smooth curve or line. This method, there's a note there, it's not super efficient and it's not the preferred method for graphing lines or any graphs, but it's what we're going to use for now. So on letter A, we're going to find the y-intercept. How do we find the y-intercept? We're going to plug in x equals 0. So if I do that, I get y equals 4 times 0 minus 1, which is -1. So the y-intercept is going to be at 0, -1. So we'll plot that. And in order to plot that point, I go left and right 0, and I go down 1, so right here at 0, -1. Then I'm going to find the x-intercept. To find the x-intercept, I put in 0 for y. So I'm going to put 0 equals 4x minus 1. Add that 1 over to both sides, so I get 1 equals 4x. Divide both sides by 4, so x is 1/4. So the y-intercept is going to be at the ordered pair 1/4 for x, 0 for y. Which means I'm going to go left and right by 1/4, which is tiny, and then up and down by 0, so that y-intercept is like super close in right there, super close to the other point we just put. And then we found 3 other ordered pairs over here. Actually, one of them repeated. We found 3, 11, and -2, -9. So from before, we had 3 over 3 up 11 to right here, and -2, -9 down here. And once all of those points are on the graph, we're going to connect them in the pattern that it's showing us. In this case, it's a straight line. So I'll use a ruler to do that. And when I draw my graphs, I will put arrows on the ends, just like that. X equals square root of y minus 1. So we're going to find the y-intercept. So the y-intercept, we put in x equals 0. So that will be 0 equals square root of y minus 1. Now what we learned in chapter 1 about solving equations with radicals is that I should square both sides of this equation, which gives me 0 equals y minus 1. Then when I add 1 to both sides, I get y equals 0. So the y-intercept is 0, 1, 0, 1, 0, 1. So I'm going to put that on my graph right here at 0, 1. And then I'm going to find the x-intercept. To find the x-intercept, I put in 0 for y. So I'll have x equals the square root of 0 minus 1. So x is the square root of -1. And we learned in chapter 1, I think it was section 3, we learned that this actually gives us the value of I. Well, I is not something I can graph on this coordinate plane, so there is no x-intercept. Good thing I had some extra ordered pairs from my other page that I can plot. So I'm going to plot 3, 10 on my graph. So go over 3, up 10, put a point. And then 2, 5 is another one. Over 2, up 5. And 1, 2. 1, 2. Okay. I can't put any values that are smaller than 0 in there because I would get those non-real numbers. Right? If I put, wait, could I put 1 in there? Yeah, I could put 1 in there. I did put 1. 1, 2. 2 minus 1. Gotcha. I didn't put 1 in there. I could put y equals 1 in. I would get out 0. Yeah, that's the smallest number. So we're going to connect these in this pattern and keep it going like that. All right, next, x squared minus 4. So finding the y-intercept. When we find the y-intercept, we put in x equals 0. So y will be 0 squared minus 4, which is -4. So the y-intercept is at 0, -4. So we're going to put that on the y-axis down here at 0, -4. And then the x-intercept, we put in 0 for y. So y equals x squared minus 4. 0 equals x squared minus 4. And to solve that, we'll go ahead and add 4 to both sides, or we could factor it actually, but I'm just going to add 4 to both sides. So we get x squared equals 4. And then I will take the square root of both sides. And I'm going to remember from previous sections that if I put the square root on both sides, then I need a plus minus on my number. So I get plus minus 2. So I got 2 values for x when I used 0 for y. So I have x-intercepts at 2, 0 and -2, 0. So I'll put those on there, 2, 0 and -2, 0. And those are actually all the same ordered pairs that I found on the previous page. So I'm just going to go ahead and connect my dots. And this actually makes a graph that you might be familiar with from other math classes called a parabola. We are going to study those parabolas extensively in future sections and chapters.